Hi everyone, this is Jeff, and I'll be showing Project 8 today, sending IMU data from the Arduino to the Raspberry Pi to the host via Wi-Fi. So I'll start off with the hardware, and just like my last video, I'm still waiting on a propeller to come in, so I can't fly my quadcopter right now because I have a broken propeller. That should come in tomorrow. So when it does, I'll post another video with this flying on the quadcopter. But for now, I just have this on my tabletop. So we have, here's just the hardware setup. Here's the Arduino. I have the IMU BN0055 connected. It's receiving power from the Arduino and is connected via SDA SCL. So that's I2C connection. So there's a serial connection between the BN0055 IMU to the Arduino. The Arduino is being powered over USB from the Raspberry Pi, and also the USB provides a serial connection to the Raspberry Pi. Raspberry Pi right now is being powered just from a wall socket, but it will be powered when I put this on a quadcopter. When I get the propeller so I can fly it, it will be powered with a portable USB charger. And then Raspberry Pi is connected over Wi-Fi to my host computer, which is then displaying the IMU information. So first I'll just show this working. So here's my host computer. You see I have a little script that's printing out IMU values as it receives them, and let me just wiggle this around. I'll bring this in view. If I wiggle this around, see the values change. So right now I have it printing out the roll, pitch, and yaw angles. The Euler angles are being printed out to the screen there. So that's the demonstration. Now getting into, I already talked about the hardware, talk about the software now. So I wrote 3 pieces of software for this project. First was the real-time code that's running on the Arduino, and that's using FreeRTOS. So that's one. I'll talk about that in a second. Second is I wrote a little Python script that runs on the Raspberry Pi, which receives the IMU messages over serial from the Arduino and transmits them over TCP/IP to the host. So it's just a little TCP/IP server. Pretty simple. And then last but not least, a little client that connects to the Raspberry Pi server and just prints everything out to the screen. So that's running on my host computer. So I'll walk through each of these, starting with the real-time code on the Arduino that is interfacing with the IMU. So like I said, it's running FreeRTOS. I'm using the Adafruit BN0055 library, which allows basically a driver for that IMU, which makes it very easy to use. I have some constants up here for delay times in tick intervals, which is how FreeRTOS wants it. I have this global queue object, so I'm using a queue to talk between tasks. Here's some definitions of the 2 tasks, which is read IMU and report IMU. So the read IMU task will interface with the IMU and read values over serial. And the report IMU task is going to send those read values over serial to the Raspberry Pi. So in our setup, we're creating a queue, only allowing 10 items in the queue, which seems to work just fine. And the data is this IMU vector3 type. And then we're creating our 2 tasks, the read IMU and report IMU. And that's about it for setup. Loop is doing nothing. And then we have our read IMU task. So what this is doing is just initializing the Adafruit sensor, the IMU sensor. If it fails to initialize, it just loops. And otherwise, it sets this setting, which I got from a tutorial on this BN0055, and then just loops forever, reads data, sends it over to queue, and delays. Another key point here is that we're setting this initialize flag to the result of the IMU sensor.begin. So if this fails to initialize, there's this global data here that the other task can use and see that something failed during initialization. The report task is just initializing serial, waiting for that initialization flag to be set by the read task, and until that happens, it just loops, and then it prints to the screen that okay, we're initialized, and then loops forever, and receives data, and if there's a message in the queue, it just prints it out over serial, and that's about it for that. So now on to the little server written in Python that runs on the Raspberry Pi. So I'll take you through this very quickly. We have a signal handler so that will allow us to gracefully catch control C's and exit properly. We have just some arguments that we're parsing so we can specify which device to read from, whether we want to echo anything we receive over serial to the screen, and the address and port to bind to. So essentially we initialize the socket, we wait for a connection in a loop, and then we open the serial line to the Arduino and read in a line at a time, parse the data, echo it if we need to, and then send it over the socket connection. And we just do that in a loop, so it's pretty simple. The client is also very simple. Again, has the signal handler to gracefully catch control C's. It just takes a host and a port which have default values set to the address of the Raspberry Pi on my network. We're just creating a socket, connecting it to the host and port of the Raspberry Pi, and then just simply in a loop we're receiving data. If we got any data, we're printing it out and then closing the socket, and that's all there is to it. Now on the Raspberry Pi, here we go. So on the Raspberry Pi, like my Project 7, I have this little init script that gets run on boot, and the init script is just running this imu.py. That's the server script. So it's just starting this on startup, and the dev ttyacm0 is the USB serial connection to the Arduino. So that is it. Thanks.